All right, derivatives of an inverse function. So let's remember in pre-cal we talked about inverses, and you switch x and y. Hopefully you remember that, the domain and range switch, etc. But you have to remember that something like this, if I just gave you this guy as your function, if you drew the inverse, it would look like this. Well, that's not a function. And so in pre-cal, what you discovered was that a function has an inverse if this original function, it has to be one-to-one. Those were the words you used in pre-cal. That the original function has to be one-to-one in order to have an inverse. And visually speaking, that means it passes both the vertical line test and the horizontal line test. And so one-to-one is kind of a pre-cal word. We've graduated from that. So we've got to use a calculus word, and that is the word monotonic. So if you see the word monotonic, that means it is one-to-one. Well, what does that really mean? That means it is strictly increasing or decreasing. Because the second that you start, I mean, if I just looked at this piece, that piece would be one-to-one, but the second I curve around and I go from decreasing to increasing, then it's not one-to-one because it would fail the horizontal line test. So that's where the calculus comes in. Okay, well, if we're doing strictly increasing or decreasing, what does that mean about the derivative? Okay, what would have to be true about the derivative is that f prime does not change sign. Because if it changes sign, then you're not going to have a monotonic function. So looking at these three pictures, don't make this harder than it is. If I give you a graph of f and ask about the inverse, would the inverse exist? Well, in other words, I'm asking, this question is the same question as is f of x monotonic? Those two questions are exactly the same thing. So is this first graph monotonic? Yes. Is this first graph strictly increasing and decreasing? Yes. The second one? No, of course not. And then the third one, is that strictly increasing or decreasing? Yes, because it's decreasing here and decreasing there. So that's what that means. Now let's get the calculus behind it. If you're in a calculus class and it asks you, does the inverse exist? You can't draw me a picture and say, oh yeah, okay, I'm just looking at it. You have to give calculus support for that. And so that's where the derivative comes into play. We have to look at the derivative and see if the derivative changes sign. So let's do letter A. If I find the derivative of 3x squared plus 1, I certainly can look there and go, gosh, that derivative is never 0. It's never undefined. So if I did a sign analysis on that, it would always be positive. The f prime would always be positive because I'm squaring something. So what does the question ask? Does f inverse exist? So yes, f inverse exists. Now what's the reason? Exists since f prime never changes sign. I like to say never changes sign because that's more specific. If you say it's always positive, that means, okay, well, if it's always negative, is the inverse, is it because it's positive? It's the fact that it never changes sign. So yes, the inverse exists since f prime never changes sign. And again, I want to be clear, that means that f is monotonic. So if the question says, is f monotonic, you would do the exact same work. All right, you try to do B and see if that one, if the inverse would exist on him. Well, the derivative, very similar. You'd have 3x squared minus 1 this time. And of course, that derivative, if I set it equal to 0, I would get a couple values there. Kind of weird ones. X equals, let's see, bring that 1 over, take the square root, it'd be plus or minus. So f prime is 0 at those two places. If I did a sign analysis, even though these numbers are weird, you should be able to do this pretty quickly because we've talked about if you have a parabola, this is an x squared, a positive x squared with two zeros, the signs are going to do this. So you say no, or just f inverse does not exist. What's the reason? Since f prime changes sign. Actually, it changes sign twice. So in other words, f is not monotonic. This function is not strictly increasing or decreasing. It has both increasing and decreasing intervals. So f is not monotonic. Not that you have to write both of those things. I'm just making sure you, oops, I spelled it out wrong over here. Monotonic. I left out a ton. I cracked myself up. Monotonic. There it is. Talking and writing at the same time. Difficult task. Monotonic. There it is. Y'all are probably thinking I'm a ding dong. Can't spell monotonic. All right. So there you go. So that's what you're going to do if it asks you if an inverse exists. Now, let's assume that the inverse exists. The other questions are going to be you finding the derivative of the inverse. Now, I'm going to tell you there's a formula, but by the time the AP test comes around, I'm telling you, you will not remember the formula. It's just a weird thing. We use this today. You don't see it unless it's on a review. And so I want to spend some time exploring inverses and talking about that, and hopefully you can remember the process so that you can remember how to do these derivatives. So let's look at two things that we know are inverses of each other. Hopefully, I'm going to erase this so I have some room to draw pictures. Hopefully you remember that x cubed and the cube root are inverses of each other. So if I drew x cubed, then I have this function. And so f of 2 very simply is 8. So in other words, it goes through the point 2, 8. And then the derivative would be 3x squared. So if I wanted to know the derivative at 2, I could plug that in. I could get 12, and I would get that right there. Now let's look at the other part. Let's look at g of x. G of x is the cube root of x. So we know that that's the inverse. It kind of looks like this. Okay, so here we said that this derivative is going to be 12 if I marked the point 2. Okay? Now on the inverse, what would g of 8 be? Well, if I plug in 8 here, the cube root of 8 is 2. So this inverse goes through the point 8, 2. This is 8, and this is 2. Now what would g prime of 8 be? Well, you can find the derivative of g. That's pretty easy. That's x to the 1/3, so that would be 1/3 x to the negative 2/3, or write it like that. And so if I plugged in 8 right here, I would get, let's see, what is 8 to the 2/3? Well, that's cube root of 8 is 2, 2 squared is 4, 4 times 3 is 12, I get 1 over 12. So the derivative right here is 1/12. Interesting. 12 and 1/12. So here's what we just figured out. we figured out that the derivatives of f and its inverse at, I call these corresponding points. In other words, f went through 2, 8. The corresponding point is 8, 2. So the ones that you're flipping. What do you notice about this number and this number? Those numbers are reciprocals. Okay, those numbers are reciprocals. So here's the problem. You're like, okay, why is this such a big deal? Why not just find the, if you have f of x, why not just find the inverse? Well, you're not going to be able to do that. So here's basically what we're going to do. And I'm going to write the steps out for you so that you can follow along. So this is what the question looks like. Well, first of all, it looks complicated. It says, how can we find, if f of x is x cubed, how can we find the derivative of the inverse at 8? Okay, the derivative of the inverse at 8. Okay, so here's what you're going to do. You're going to find the corresponding point. Now again, I know on this one it is very simple for you to go, just find the stinking inverse and then find the derivative of it and then plug in 8. Yes, but if you look at the problems that you're going to be given, you're not going to be able to do that as easily, I promise. So you're going to have to learn how to do it this way. You're going to be given a chart, so that's not going to happen. So you're going to find the corresponding point. What that means is this, and I'm going to label my steps so you know what I'm doing. This is the x value on the inverse. So if it's the x value on the inverse, then it is the y value on f. So I'm going to set my function f equal to that value and solve. Now it's going to be something that you can solve in your head, obviously, if I give you a non-calculator part, and there can only be one answer. Friends, if there's more than one answer, then it's not a function. So it's not monotonic. So there only has to be one. So don't think, well, what if there's more than one? There can't be more than one. So I get x equals 2. So you have found the corresponding point. So what are you going to do then? It's like, of those graphs we have, you want to know the derivative at this point. What you just found, you said, okay, let me do it in a different color. I have found that corresponding point is up here. The next thing I want to do is I want to find the derivative on f of that corresponding point. So I'm going to take f prime, which is 3x squared, and I am going to plug in the value that I got from number 1. And I'm going to evaluate the derivative at that point, which I got 12. So I've just found that the derivative of this guy is 12. The last step is the easy one. I know that the derivative of my inverse is the reciprocal, so I'm just going to flip. So the derivative of the inverse is going to be, and my answer would be 1/12. Now here's why I say I don't bother with the formula. Okay, if f, I'm going to show it to you, but I think you'll see why. Notice that I did not do the formula to do that problem. So also remember from pre-cal, if f and g are inverses, their composition equals x. So I could write that f, if they're inverses, to get in the notation of what we have here, is equal to x. Okay, so let's do the derivative of that. You're like, okay, this is a composition, so I have to remember the chain rule. It would be the derivative times the inner times the derivative of the inner function, which would be the derivative of the inverse of x. Now on the right side, I would just get 1. Now what I'm actually trying to solve for, notice, look at what I'm looking for is this part right here. So if I solve for that, I would get the derivative of the inverse of x is 1 over f prime of f inverse of x. And within that, you can kind of see the 3 steps. But again, you're not going to remember that formula. So here you're finding the corresponding point. You're plugging it into the derivative, and then you're taking the reciprocal. So I can remember the 3 steps a lot easier than I can remember that formula. So let's practice with the next couple of examples. So find the derivative of the inverse of 1/2 if f of x equals cosine of x. So let's do our steps. It's the x value of the inverse. So I'm going to plug that in for the y value of my function. So where is cosine of x equal to 1/2? Now remember I said there can only be one answer. Notice this guy gave me an interval, and that's why they had to do that. Because if I said on the unit circle, hey guys, where is cosine 1/2? Well, you could give me lots of different answers. And so if there's more than one, they have to give you that interval. So where is cosine equal to 1/2? On that interval, and you would say x would be pi over 3. That's step 1. Okay, let's do step 2. Step 2 is take the derivative of f and evaluate it at the x value that you just got. So f prime of pi over 3 would be negative sine of pi over 3. So pi over 3 is here. The negative of that would be, the opposite of that would be negative square root 3 over 2. The third step, lovely, take the reciprocal, and that is your answer. So the derivative of the inverse at 1/2 is negative 2 over square root 3. Remember, calculus doesn't care if you rationalize. Yes, if it's multiple choice, you would have to get a similar answer, but if it's free response, I don't touch it. I don't do more work than I need to. So I'm going to leave the answer just like that. Okay, stop the video and you see if you can do number 4 all on your own. Here we go. Step 1. You set this, your function, equal to 7. So negative 2x cubed is 2. So x cubed is negative 1. So x is negative 1. That's step 1. Step 2. Take the derivative of f, which would be negative 6x squared, and plug in the x value that you got. So negative 6 times negative 1 squared, watch those signs, is negative 6. Third step, and that's going to be your answer, is you take the reciprocal. So the derivative of the inverse at 7 is going to be negative 1/6. And there you go. Now, I think you have a homework question that has a chart, and that is, you've got to be able to read that. I will also tell you on number, let's see here. On number 6, again, on number 6 on your homework, this could certainly be on a calculator part. Now your test is all non-calculator, so I've got to make this thing easy for you to solve. I will tell you on number 6, this could be on a calculator portion on the AP exam, and this equation is a very difficult one, and so number 6 is like that on your homework. So you're not expected to kind of get that in your head. You can use a calculator to do the solving step. Remember, anytime you have a solving, like you couldn't get this, that would be y1, y2, and you see where they intersect. So use that on number 6. All right, All right, peace out.